Okay, so in today's video we're going to be using the rational zero theorem to factor a polynomial and find the zeros of a polynomial of degree 4. So the first thing you got to do when you're using the rational zero theorem is to find all the factors of p, which is in this case 6, and list them out. So we have plus or minus 6, plus or minus 1, plus or minus 2, plus or minus 3, and that's all the factors of 6. And you have to put that over the factors of q. So the factors of 2, which in this case q is equal to 2, the factors of 2 are plus or minus 2, then plus or minus 1. And then we have to pick one of the combinations between the two. So let's try, and we have to test them out to see if they are the zeros of the function. So these are all the possible candidates for the zeros of the function. And we have to test them out using synthetic division. So let's test out positive 3 over positive 1. So positive 3, which is up here in the top right, divided by positive 1 is one of the candidates. So we'll try positive 3. So we got 2, 3, negative 12, negative 7, and 6. Sorry if you can hear honking in the background. So that's 2. 2 times 3 is 6. And then 3 plus 6 is 9. 9 times 3 is 27. Negative 12 plus 27 is 15. 15 times 3 is 45. Negative 7 plus 45 is 38. 38 times 3 is 106. So that's equal to 112. So this is not a zero of the function because we have a remainder here that's not equal to 0. Now let's try positive 1/2. So if we try positive 1/2, we got 2, 3, negative 12, negative 7, and then 6 again. And then drop down to 2. 2 times 1/2 is 1. 3 plus 1 is 4. 4 times 1/2 is 2. Negative 12 plus 2 is negative 10. Negative 10 times 1/2 is negative 5. Negative 7 minus 5 is negative 12. Negative 12 times 1/2 is negative 6. And 6 minus 6 is 0. So because we have this 0 right here, 1/2 is a zero of the function. So this is a zero of the function. And then now these can be our new candidate, or sorry, not our new candidates. These can be our new coefficients for our new polynomial function. So next in our candidates we can try, let's try positive 2. So we can divide all these by 2, and then we can get, for the coefficients of the new polynomial function, we can get 1, 2, negative 5, and negative 6. Drop down the 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. Negative 5 plus 8 is 3. 3 times 2 is 6. And negative 6 plus 6 is 0. So positive 2 is another zero of the function. And now now that this is a quadratic, we can see if we can factor it. Our new polynomial function is x squared plus x plus 3. And then solve for equals 0. And we can see that we actually can factor this. So this factors into x plus 3 times x plus 1. 3 and 1 add up to 4, and then 3 times 1 adds up to, or 3 times 1 multiplies to 3. So the factored form of the polynomial, of this polynomial, the factored form, is x minus 1/2 times x minus 2 times x plus 3 times x plus 1 equals 0. And we can see that the zeros of the function for this graph, if we solve for each individual product, is x equals 1/2, x equals 2, x equals -3, and x equals -1. So I hope that helped with this example. I'll be doing another example with a polynomial of degree 7 that'll be more complicated and more in depth if you need to look at that example instead. If you have any questions, put it in the comments below. I hope you guys have a great day, and I'll see you in the next video.